Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lectures on probability and statistics course. In the first two lectures, lecture 1 and lecture 2, we have discussed about the basic principle of counting, permutation, combination, and little bit related topics with some examples. In today's lecture, we are going to start with a sample space and what are the events that thing we'll be discussing. Now, consider an experiment whose outcome is not predictable with certainty. What does it mean? That you are doing an experiment whose outcomes is not certain. Suppose you have a balloon and you are doing an experiment that, okay, you are putting a scissor on it. Definitely it will blast, right? So it is a certain event. But there are some events that may not have certain outcome. Like you are flipping a coin and then it has no certainty that it can appear as an head, it can appear as a tail. So we are going to consider an event whose outcome is not predictable. So you don't know that what outcome is going to come. Now the set of all possible outcomes of an event is called the sample space and it is denoted by S. So we'll consider such kind of experiment whose outcome is not predictable. Therefore it has several outcomes. Then the set of all possible outcomes of an experiment is called the sample space and it is denoted by this S. It is denoted by S. Now, some example. If the outcome of an experiment consists of the determination of the sex of a newborn child, then what are the possible outcomes you will have? Definitely we'll have that either there are two possibilities. It can be a girl or it can be a boy. So if it is a girl, we are considering it is G and otherwise it is a boy. So this is the all possible outcomes and then the sample space is this one. Next, if the outcome of an experiment is the order of finish in a race among the 7 horses having position 1, 2, 3 up to 7. So there is a race where 7 horses are participating. So how many ways their finishing line will be there? Like horse 1 can be the first, horse 1 can be second, horse 1 can be the last one, right? Similarly, horse 2 can be the first, horse 2 can be second, third. So all possibilities are there. So think of it, what is the sample space in this case? We have 7 horses. So anything can happen. All 7 horses can have the opportunity to get the first position. Correct? So once the first position is already occupied, then how many are remaining? There are 6 horses will be there who will get the second position. In this way, how many different kind of possibilities you will have? How many different kind of outcomes you will have? Yes, it is the all permutation. All 7 factorial permutation of the numbers 1 to up to 7. Correct? So in this case, like one of the outcome maybe, let me write down one of the outcome 2, 4, 1, 6, 3, 5, 7, like that. So it means that the horse 2 got the first position, horse number 4 got the second position, horse number 1 got the third position, and so on. So this is one example. In this way, how many different outcomes you will have? Because that means all permutations of the number 1 to up to 7. So there are 7 factorial number of outcomes will be there. So this is the sample space in this case. Yes, as we discussed, all 7 factorial permutation of the number 1 to 3 up to 7. I hope it is clear. Okay. Another example. Suppose we are flipping two coins together. Then what are the possibilities are there? What are the all possible outcomes are there? Yes, in this case, what should be the sample space? We can easily understand that maybe both the coins are head. Possible? So this is one outcome. Maybe first one is head and the second one is tail. Another outcome. Second one is first one is tail, second one is head, and both of them are tail. So these are the four possible outcomes we can have in this experiment. Clear? Yes, as we discussed, the sample space in this case, it is this one. Now again, if we toss two dice together, then what are all the possible outcomes you can have? Now we all know a dice has six faces, 1, 2, 3, up to 6. So if I'm tossing two dice together, what can be the possibilities? One of the outcome, maybe I'm taking that one of the outcome is in the first dice you got the number 2 and in the second one you got the number 5. Possible? This is one of the outcome. In this way, how many different outcome you can have? Now this one you can again think it as a basic principle of counting way. So basically you will have two, like for the first dice you will have one kind of possibilities and for the second one you have another one. So you have basically two position. So for the first one, how many possibilities you have? You have 6 choices. For the second dice also you have 6 choices. So for each of the first one you have 6 choices for the second one. So how many total number of different choices you will have? There are 36 number of possible outcomes. Correct? So what are they? So in this case, the sample space is all the order pair of this kind I comma j type, where I comma j is equal to 1, 2, 3 up to 6. These are all possible outcomes. And cardinality of this set is 36. So some of the possible events are 2, 5. Like some of the possible outcomes is one is 2, 5. Another one may be 1, 6. Another can be 6, 6. But in this way, you have 36 this kind of choices. I hope it is clear. Yes, as you discussed, this could be the sample space for this case. Now, definition of events in probability. An event in any collection. An event is any collection or subset of outcomes contained in the sample space S. So basically, we have understood that sample space is a set. Set of what? Set of all possible outcomes. So a sample space is a set. And what do you mean by an event? An event is any collection of outcomes. That means any subset of the outcome set, of the sample space set. You called it as an event. So an event is any collection of outcomes contained in the sample space S. We'll discuss some example. It will be more clear in that case. An event is simple if it consists of exactly one outcome and is compounded if it consists of more than one outcome. Again, so there are two kind of events we'll have. One is a simple event, another one is compound event. We'll understand that through example. Consider an experiment in which each of the three vehicles taking a particular freeway exit turns left or right at the end of the exit lamp. Right? So basically you have three vehicles. They are going in a particular freeway. So at the exit lamp, there will be two directions. One is left, one is right. So these vehicles can get either left or right, that direction, so that they will exit this freeway. So how many different way this kind of directions are possible for these three vehicles? Vehicle 1, vehicle 2, vehicle 3 maybe you can consider. So maybe one of the outcome, I may discuss that. Maybe the first vehicle got left direction second vehicle got right direction, third vehicle got again left direction. Possible? This is one outcome. Now you think that what are the all possible outcomes? That means in this case, what is the sample space? So make the video pause, think of it, and first you count how many such possibilities are there, and then you write down the sample space, maybe in your notebook or in the comment box. Yes, you again consider that you have a 3 consecutive kind of a task. For the first one, how many choices you have for the first vehicle? It can go get 2 different choices, right? Either left or right. Second one can also get 2 different choices, either left or right. Third one can also get either left or right. So all together, by basic principle of counting, you will have 2 into 2 into 2. There are 8 possible outcomes. Correct? And what are these outcomes? They are this list. So all 3 of them are getting left direction. First one got the right, other 2 got left. Right? In this way, you got that 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. Clear? Now we'll discuss that what are the events which are simple event, and we'll try to find out some compounded event as well. Now each of the individual event, like the event of having all the vehicle got the left direction. What is that event? It is the event E1 is basically LLL. So how many elements are there in this event? Only one, so it's a simple one. What is that event where the first car got the right direction and the other 2 got left direction? So it is the event 2 and it is RLL and so on. In this way we have 8 number of simple events. Clear? So as we discussed, thus there are 8 simple events which are E1, E2 and so on up to E8. Now try to get some compound event. Let us discuss an example. The event, consider the event that exactly one of the 3 vehicles turns right. Now think the event that exactly one of the 3 vehicles turns right. What is that event? It should be the event A equal to exactly one of the 3 vehicles. So it is RLL, LRL and LLR. This is that event that has exactly one of the 3 vehicles turn right. I hope it is clear. So now look at this event. It has more than one number of outcomes, right? So this event is a compounded event. Whereas the event E1, E2, all of them were the simple event. Clear? Let me move to another example of compound event. The event that at most one of the vehicle turns right. Now in this case, it says that at most one. So it can be 0 or 1 then, because you are saying at most one of them turns right. So in this case, what should be the event? At most one, that means it can be 0 also. 0 number of event turns right. That means it will start with LLL, this event. And then 1 got the right hand direction. So it is RLL, LRL, and it is LLR. This event is also a compounded event because it has more than one number of outcomes. Yes, as we discussed, this one. Now what about this one? The event that all 3 vehicles turns in the same direction. Now can you tell me what is that? This event, all 3 vehicles turn in the same direction. So it can be either left, 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 or it is the right, right, and right. So these are all examples of compounded event. I hope it is very much clear to you. Now you see that this is the sample space, which is basically a set of all possible outcomes. So this is a set. Now these are the events. These are the subset of the set S. This is the event subset of the set S. Correct? So an event is a collection of outcomes of the sample space. So it is a subset of the sample space X. Subset. Okay. Now one more thing. Suppose that when the experiment is performed, the outcome is LLL. Suppose you got this outcome LLL. Then what you can say that, in this case, what you can say, suppose an experiment you have performed and you got this outcome. In this case, what you can say, the event U1 occurred, right? The event B also occurred, the event C also occurred. Yes or no? I have performed this experiment, I got an outcome LLL. In this case, we can say that U1 also occurred, but the event B also occurred, no? Even C also occurred, correct? So we can have the note that when an experiment is performed, in general, exactly one simple event will occur, but many compounded events will occur simultaneously. So from this example, we can make this statement that when an experiment is performed, in general, exactly one simple event will occur, but many compounded events will occur simultaneously. I hope it is clear. Okay, let me move to the next concept. Now we have seen that a sample space is a collection of all outcomes. So basically it's a set. A sample space is a set. We have also seen that events are the subset of the set, sample space set, right? So whatever operations we have learned in set theory, union, intersection, complement, all these things will work here as well, right? So what event operation in probability. So we are going to discuss same thing. The complement of an event A is denoted by A complement. We can sometimes denote it by A dashed as well. Is the set of all outcomes in the sample space that are not contained in A. So these are the elements which are not in A. The outcomes which are not in A. That you called it as A complement or A dash. The union of two events A and B is denoted by A union B, and read it as A or B. Is the event consist of all outcomes that are either in A or in B or in both the events. That is, all outcome is in at least one of the events. So same like set theory. Then we have the intersection. The intersection of two events A and B is denoted by A intersection B, and we read it as A and B is the event consisting of all outcomes that are in both in A and in B. Then we have this mutually exclusive or disjoint event. This is same as disjoint set. So let phi denote the null event. That means the event that consisting of no outcomes. Basically in our set theory you have learned it as null set. So if A intersection B is equal to phi, so if two events A and B, their intersection is a null event, then we can say that A and B are mutually exclusive or disjoint event. Right? So very easy, same as set theory. Like this thing, look at this event B and event C. They are not mutually exclusive event, right? Because their intersection is not null event, because they have a common one. Whereas the event C and the event A, the event C and the event A are mutually exclusive. Why? Because their intersection is a null event. Therefore, they are the mutually exclusive. And then again, for the set theory, you have learned these things as a Venn diagram. Same thing will happen here also. This is the Venn diagram of the event A and B, right? So A, then this is the shaded region is A intersection B, correct? So this part is the intersection B. Then A union B means either in A or in B, so the total one. Then A complement, A dash or A complement, it is the outside the set which are not in A, all the outcomes. And mutually exclusive means there is no common element between these two. There is no common outcomes. Correct? So in set theory, we know this kind of laws also hold: commutative laws, associative law, distributive law. So all law will happen in case of probability case also. So in case of an event and the sample space. So basically a sample space is the universal set, and all of its events are the subset of that universal set. Okay. And then we know that in case of a set, we have this famous law, or De Morgan's law will also satisfy. So De Morgan's law are, if E union F whole complement you will take, it will be E complement intersection F complement. So E union F whole complement is equal to E complement intersection F complement. So they are individual complements intersection. And similarly, E intersection F whole complement equal to E complement union F complement. So these are called the De Morgan's law, and this can be extended for n number of events. So union of n number of events and their whole complement is equal to all of their individual complements and their intersection. And similarly, we can also have this one, that intersection of I equal to 1 to n ei equal to I equal to 1 to n ei whole complement, right? So these things will also happen for the case of probability. Okay, so in the next lecture we'll discuss about the probability, some axioms of probability, and we'll slowly move into the core part of probability. Till now we have discussed only the counting things and then the event, sample space. In the next lecture we'll discuss about the probability. And all the contents for this today's lecture we have taken from these two books, right? So almost all the content we have taken from this book. So if you like the video, please give your feedback. I hope this is useful. We'll meet in the next lecture. Thank you very much.